have quite a nice lecture. It is 5 p.m. London time. It's 7 p.m. Jerusalem time. So we'll just wait for all the other participants. I will share my screen with you as well, so that you can see the presentation. I'm gonna just lower down myself as well. We'll just wait for a few more seconds whilst everybody can join us. Again, today is our lecture is going to continue on basics of statistics. As always, you may enter the chat. You can type in your question in here. If you have any questions, عندك أي سؤال, you can always write the question in here. And I'd be more than happy and delighted to answer them in due course. Meanwhile, I'll give you just another minute or so, and we're going to kickstart our third lecture in this series of 7 lectures. As I've pointed out before, we had the introduction, which was 2 weeks ago. Last week, we spoke a little bit about basic statistics, and it was lecture 1. I thought I'd divide it into 2 lectures. So today we're going to go for lecture 2, and then we're going to carry on with 4 more lectures. By the end of it, hopefully, we will start writing our own papers. Anyway, so I think at this stage, I'm going to start. It's on recording for people who will miss it live. Yeah, and I will be downloading them soon after I figure out how, hopefully, into YouTube. If I can ask you, can you all to mute your microphones? That would be great. And then we can kickstart and hopefully do our lecture. So this is just a picture I've taken in Cambridge. And as I said, today is our second lecture in basics of statistics. So we're going to carry on with that. And then we will discuss various steps. So just as for our knowledge, there is different types of studies. If you could kindly mute yourselves, that would be great. I'm just going to ask you to mute, if that's all right, because that will help us go through the lecture smoothly. Anyway, so we'll carry on at the moment about study types in health. We know that there are different study types. All of you should know them by year 2, medical students. So أقلهم is case report, where you write the details of or history of a small number of individuals or cases and publish them. And this is the least evidence. Then you have cross-sectional. You go with a survey in your country and you look into a slash of people of how they are performing. So you're here calculating the prevalence. Yeah, at the A موجود breast cancer in X city. Yeah, case control. This compares between groups of people, and this is higher evidence. And cohort, which means that you are going to take a group يعني cohort, and then you will follow them throughout the process. And there is a quasi-experiment. It is a non-randomized trial. And there you have the randomized trial and the highest level, which we spoke last lecture about, which is meta-analysis and systematic review. This is just a kind of a regrab. So now you have collected all the data and you've collected weights. Yeah, يبقى جمعت كل البيانات, and then you wanted to put them on a graph, as we said. So you have 2 types of graphs that will emerge. بالآخر حيطلع معك واحد من الجرافs الاثنين اللي هنا. يا ما حيكون منحرف, which means that the data are not following normal distribution, and this we call it skewed, just as a revision. Or they will be normal distribution, which means إنه حتكون في التوزيع الطبيعي تبعها، إنه أغلب الناس وزنهم ما بين 70 و 90. Yeah, لكن أحيانا ممكن تلاقي society where there is people who have mostly all over 100 kilograms. Yeah, so that's skewed. Or most of them are thin. Then that's again skewing. All right. So just as a kind of to give you the heads up. So simply putting these big terms, we have 2 statistical things, procedures. واحد بيسموهم parametric and the other is called non-parametric. It's a big name and a big word, but simply putting it, in parametric statistics, these procedures assume that the population follows a normal distribution. يعني the parameters are in fact such values as the mean and standard. يعني your study is following that normal distribution that you saw. In non-parametric بمعنى you cannot predict the population. يعني انت مش عارف ايش اللي حيصير بالpopulation تبعتك, and if the sample is there, is that sample going to be representative of the population or not? And it's likely to be skewed data, okay? Simply putting it. So now let's start with the parametric tests. يعني tests that will test the normal distribution. How important are they? Well, total papers, 1/3 of the papers quote these tests. Yeah, هتلاقي فيهم التستات هاي. When are they used? They used to compare samples of normally distributed data. يعني should not be used if data are skewed. And now you know what's the difference. Common parametric test is the t-test, or they call it t-students test, أو chi-square test. يعني x chi square يعني تربيع test. Okay, we will not go into details of these tests. مش مطلوب منك. This is a statistician job. المطلوب منك, what is relevant to you, is to understand the concept of them. Yeah, so don't overwhelm yourself. So there is something called ANOVA. لو سمعت فيها, if you heard it, that's analysis of variance. يعني فرضاً, you have a population and you want to see, is there any link between food and length, food and weight? Yeah, so those are two variants, food and something, let's say, and the weight. Yeah, so those are two variants. So it's a group of statistical techniques معينة بيستخدموهم statisticians used to compare the means of two or more samples to see whether they come from the same population. اللي هي null hypothesis. So you want to test the hypothesis but using two samples. So أخذت sample, let's say, from a city X and city Y. Both cities are, let's say, in Egypt. You want to see whether you test these samples, whether they are relevant and they have the same mean that the normal population of Egypt would have it. These techniques also allow for independent variables which may have an effect. لاحظوا, ANOVA is for two or more samples. Yeah. What is relevant to you is to always check the p-value, which we have discussed in the last presentation. So what are the parametric tests? We have the t-test, also known as students test. If we have some time later on at the end, I'll show you why it's called students test. And it's typically used to compare just two samples. They test the probability that the samples come from a population with the same mean value. يعني بتاخد sample, let's say you're living in Turkey. You take a sample from Istanbul and another little sample from Izmir. And you would say, okay, is that two samples, are they relevant to the whole population of Turkey or are they not? So that's when you come and test it and see the p-value of it. Another test just to be aware of, it's called chi-square test. Okay, so let's have an example. So there is a new bronchodilator in the market, and that bronchodilator, we've given it to 200 adult patients, and we've divided it into people who have new bronchodilator, and then we've given it a placebo. A placebo بمعنى that's something that mimics the inhaler but contains nothing, just puffs of air. Okay, but this one contains the real bronchodilator. So we've divided the sample and we followed the patients for 3 months. Those who were giving the bronchodilator, the new one, and those who were giving just the placebo, and they didn't know. And let's see if there was any difference. So those with the bronchodilator, the peak flow rate increased by 96 liters per minute with a standard deviation of 58. Those with the placebo, the peak rate increased also by 70 liters per minute, yeah, with a standard deviation of 52. Your question is, so the hypothesis, a null hypothesis, there is no difference between the bronchodilator and placebo. هذا default تبعنا صح from the last lecture. So in this scenario, we did two statistics. So because we had two samples. So we have sample A, which is the people with a bronchodilator, and 200 adults on the placebo as well. So we have two samples. So we will use what test to compare two samples? We use here t-test for statistics. أعطيناها للstatistician and they tested our hypothesis. The hypothesis is that there is no significant difference. So they calculated their عملوا الحسابات طلعت 11. I don't know what does that mean. But they calculate for us also the p-value, and they found that the p-value is 0.001, which is highly significant. If you remember from last, therefore, very unlikely, 1 in 1,000 chance that the null hypothesis is correct. يبقى null hypothesis is rejected, زي ما بتتذكروا, and we accept that there is a significant difference between the new bronchodilator and the placebo. بمعنى إنه the new bronchodilator is effective. Yeah? Does that make so? We reject the hypothesis and conclude that the new bronchodilator is significantly better than placebo. But remember, we have to follow the normal distribution لما تستخدم التست هذا. So another test or other tests called non-parametric. Yeah? And there is another test called Mann-Whitney test. It's part of the non-parametric. وزي ما حكينا, as we said, non-parametric uses data when they are not normally distributed. يعني they are skewed. لما اجيت حطيت الداتا, لقيت that they are skewed. And if you remember, we use here the median, yeah, from the first lecture. So not appropriate for a parametric test. So let's give an example. There is a GP, طبيب عام, they have their own clinic, and they introduced a new triage system in their clinic. And they were interested, كان السؤال تبعهم, whether the age of patients attending for the triage appointment was different to that of the patients who made an emergency appointment with GP. في الUK عندك الجي بي اللي هو الفاميلي ميديسن دكتور بيشوف العيانين. فواحد من الجي بي قال لك طب انا احط ممرضه, I will put a nurse who will help me in triaging so that I'm not seeing all the patients. There are some patients that can be seen by the nurse at a later stage as an elective, not an emergency. But what he's done is he put a total of 646 patients saw the triage nurse, and he found after a period of time that a total of 500 saw himself, الGP. فراح حط statistics على age against the patients who went to the nurse, okay? And so the nurse first. لقى إنه data are not following a normal distribution. As you can see, they are a little bit skewed towards the right. يعني في أكتر باتجاه اليمين, yeah, as age-wise. So he thought in himself, okay, so they're uneven, they're skewed, which means that I have to use a non-parametric test to test the two samples. Anyway, so the total patients of 646, as we said, those saw the nurse, whereas 530 saw the GP. They calculated the median. وعرفنا ليش median? Because data are skewed. صحيح. So the age was 50, whereas here the age was 46. And because we can also calculate the interquartile range, they've calculated range 1 and 3 and 1 and 3. So the question the GP is raising, that the null hypothesis would be that there is no difference between the ages of these two groups. مش هذا الديفولت. This is the null hypothesis. That's the standard. So you want to prove or disprove this. So you'd need to figure out a test. The best test in this scenario would be a non-parametric test. So you ask the statistician and they do the Mann-Whitney U test, طويل الاسم, to test the hypothesis, whether the hypothesis that says that there is no difference is correct. And the hypothesis, that's the difference. And they've calculated a U value, مش مهم تعرفوها, which is this number. But they've calculated something that you need to know, which is the p-value. And they found that the p-value is 0.001. So ignore the U value, but concentrate on the p. Suggest that the triage nurse patient were very highly significantly older than those who saw the GP. Yeah, so looking at those numbers, you'd think, okay, the median is 50, the median is 46. It's likely that there is no difference. However, when they tested it, they found that actually it is very highly significantly, and that those who actually saw the nurse were much, much older. Yeah. في other types of tests, just be aware of them, and those are non-parametric tests, which is a Wilcoxon signed rank test, Chrysler, Wallace, Friedman, أسماء بس تعرفوها لما تقرأوا papers. So just to re-grab this first bit, we have parametric and non-parametric data. The parametric, usually they follow the normal distribution. And those are the tests that we can use. In non-parametric, they are skewed, so they don't follow the normal distribution. And it's usually median that we find. And if we want to test the sample against the hypothesis, we use one of those tests. هتكون اللي بدك تعرفه. How life works. Our life is simply putting, there is a trigger, so you study. And that trigger usually is exposed to some sort of an environment, so that's called an exposure. And there should be an outcome. غالبا بيحكوا إن تدرس تنجح. بس أحيانا إن تدرس ممكن أن تخفق بسبب الظروف. Yeah? So that's the exposure. Somebody who has studied and he was exposed to noise, a lot of hassle, stress, then he failed. And another person studied the same material, but then it was a quiet, nice area. He concentrated and he succeeded. So you can measure either the exposure on the outcome, or you can ask yourself what caused the outcome to happen in this particular person. يعني, you can look at it a different way. So why did this man succeed? Oh yeah, because he was exposed to a different environment during this study. As a conclusion, we have two things, an exposure and an outcome. You can either يا إما في حياتك حتوصل للoutcome وترجع برجوع, so you go back retrospectively to the exposure. يعني لقيت واحد عنده cancer lung, you'd ask, did you smoke? And you know that he was exposed to smoke. أو واحد حتخليه smoke, which is illegal of course, and then you'd follow him for years and you will know that the outcome could be cancer. Those are two different things that I want you just to have in mind. Why? Because the next phase of statistics is a bit tricky. There is something called risk ratio, أو معدل الخطر, often referred as relative risk. When to use it? Relative risk is used in cohort studies. حطها بين قوسين وتذكرها. Make it as your default. Risk ratio is cohort studies. It's a prospective study that follow a group. Okay, ومن هنا اجت كلمة cohort. From here we derive cohort. Cohort معناتها group. Over a period of time and investigate the effect of a treatment on the risk or risk factor. So it's basically a prospective study. You follow them throughout that to find out what's the risk ratio of this happening. So if you follow the smokers for a long period, and you will see what's the risk of them getting a lung cancer. Yeah. So that's a cohort study and risk. So there, what does it mean? إيش معناها? We have risk and risk ratio. نبدأ بالsimple things عشان تفهموها كويس. The risk itself is the probability that an event will happen. Sorry, there is a missing T. Calculated by the number of people at risk. So if 1 in every 100 patients suffers a side effect from a drug of some sort, the risk is 1 over 100, which is 0.01, isn't it? So that's the risk, الخطر. But the risk ratio, معدل الخطر, is calculated by dividing the risk in the treated or exposed group by the risk in the control or unexposed group. يعني لو جدنا مدخنين وغير مدخنين وشفنا كم واحد منهم had the risk, which is lung cancer, and you divide it by both together and compare it, that tells you the risk ratio. Something just to bear in mind is number 1. إذا طلعتوا من هاي المحاضرة كلها برقم 1, you will be number 1. Okay, so if relative risk was 1, which means that there is no difference in risk. بما معناه إنه اللي أخذ واللي ما أخذش 1. لاحظوا بالعربي حتى 1. If risk ratio is more than 1, the rate that the event will happen is increased compared to the controls. يعني معناته المعدل حيزيد في الناس exposed. Whereas if R relative risk, and I say RR, risk ratio, is below 1, that means that the event is reduced. Let's go for an example, isn't it? Everybody is hungry for an example. So, you know, we play football, there are players, and look at this badly, you know, kind of topping on the toes and breaking. So I thought an example would be risk ratio about footballers. So we have people who are regular footballers, and we take 1,000 people, whereas a sample of non-footballers is 1,000. So this is the footballers and the control. ولاحظوا, we started from the footballers and we will follow them up. أرجوكم, remember this. So followed up, حطيتها بيك كبير, for those playing football was significant in the injuries that they will receive. بدنا نشوف كم واحد فيهم will have a broken leg. So after following for a year, we found that those who were regular footballers have 12 broken legs, whereas those who were non-footballers had 4. Now the question becomes, what is the risk? So the risk is 12 for those footballers over 1,000, which is this number, whereas the risk for the non-footballers is 4 over this number, which is 4 in 1,000. Yeah? So that's the risk. اللي حكينا أول واحد. But we need to calculate something more, the risk ratio. The risk ratio would be the risk in the footballers على a risk that is in non-footballers, which is 3. Now 3 is a risk ratio, but we don't know whether this is significant or not. فرحنا عطينا الرقم هذا للstatistician, and they've calculated for us the confidence interval, which is 95%. And we said how confident we are that the mean will be in that 95%. And he calculated it for us and found that it's 0.95 لحد 9. تذكروا في رقم واحد ما بين هذا الرقم لهذا. يعني from 0.9 to 9 there is number 1. And this is an issue. So as confidence intervals includes the value of 1, yeah, we cannot exclude the possibility that there was no difference in the risk. However, given these results, further investigation would be clearly be warranted. يعني لو لاحظتوا إنه عملنا الكونفيدنس انترفال للريسك ريشيو لقينا إنه it is between 0.9 و 9. This is a very wide confidence interval, isn't it? وفيها رقم واحد قلنا من الأول that there is no difference. يبقى بالتالي تسقط يبقى بتفوز معانا مين؟ النول hypothesis. لكن given the fact that the confidence interval is very wide, وحكينا من الأول إنه confidence interval depends on the sample size, perhaps if we increase the sample size, we will be more confident. And that's what they write in the papers, that clearly more investigation would be warranted. يعني يمكن لو أخذت 10,000 footballers versus 10,000 non-footballers, you will have a better idea about this test. This is the first part, the big chunk. The second big chunk is something called odds ratio. هي الاحتماليات. Okay? Odds لحالها كده half on its own means that the number of times an event had happened. Okay? Over the number of times it didn't happen. Yeah? So odds is the number of events that had happened already. يعني حاجة حصلت. We're not following it up. لاحظوا. في ratio, our risk, we were following them up. Here, something that has happened already over the number of times that it doesn't happen. Just remember this. So let's say here, if 1 in every 100 patients suffers a side effect from a drug, الodds تبعتهم هو 1 إلى 99. يعني واحد suffered that effect و99 didn't. For risk, it was different. We were following them up. Remember this, please. So the calculation would be 0.01. Okay? لحتى الآن, it's simple. The odds ratio is the odds of having been exposed to the risk على الcontrol group. So if the odds ratio again is 1, that means that there is no difference in the risk between the groups. يعني the odds in each group are the same. يعني الprobability احتمالية إنه الevent has happened in that group is the same. If it's more than 1, the event is increased in the patients who have been exposed to the risk. If it's less than 1, the rate is reduced. Again, all you need to remember, there's something called odd ratio. These patients had already the outcome, يعني حاجة حصلت, and there's number one that I need to remember, that there is no difference. If it's more than one, means that the rate of the event happening has increased. Less than one, the rate of the event has decreased. So if the confidence interval for an odd ratio does not include one, يعني ما فيهاش واحد, that there is no difference in odds, it is statistically significant, similar to anything about odds or risks. Anyway, this might be a bit too complicated, so let's go for an example. We took people who had knee injury. Yeah, we took 100, a sample of 100 people, and people with no knee injury, another 100. لاحظوا هنا أخذنا knee injury already. بالريسك أخذنا الفوتبولرز بالأول. So this is different. هنا الأوتكم كان خلاص عارفين هذول injured وهذول non injured. And then we match them for age and sex عشان يكونوا الاثنين متناسقين. أكدنا إنه يكونوا the two samples that are very close to each other in regards to age and sex. And then we asked them a question: how many of them did ski? يعني راحوا تزلجوا, and how many of those didn't ski? And we find that those who had knee injury, 40 of them skied, and those who didn't were 60. Whereas those with no knee injury, اللي هو الكنترول, 20 of them skied, and 80 them didn't ski. Sorry, there is a didn't here, yeah? So that means that the odds of being a skier, يعني the odds of you having the knee injury from being a skier is, or because of the skiing itself, is 40 over 60, yeah, which is 0.66. بمعنى those who skied in ratio to those who didn't ski with knee injury is 40 to 6, which is 0.6. Whereas here in control, the odds of being a skier and having no injury is 20 to 80, which is 0.25. Okay? So now a question is, what's the odd ratio? Again, you'll take the odds from those with an outcome, so 0.6, and divide it by those who have no knee injury and see what's the odds ratio, and it's going to be 2. Again, you don't know what's 2, it's more than 1, which means that the number of skiers in the cases is higher than the numbers of skiers in the control. بمعنى إنه عدد الناس اللي had a knee injury and didn't have any injury, the skiers were much higher than those who were non-skiers. Yeah, so we look in a different way. We look backwards. We don't follow them up. To make it simply, sometimes they can say, oh, there is 164% increase in odds of injured knees among skiers. وهذا هو نفس المعنى إنه the odds ratio is 0.66 over 0.225. Again, remember, if the confidence interval includes 1, that means that the null hypothesis wins. If it doesn't include 1, it means that the null hypothesis loses, rejects. So we asked a statistician to calculate for us the confidence interval, and they calculated for us from 1.4 to 5, which means that it doesn't have the number 1. This means that the skiers are more likely to get a knee injury than non-skiers. Okay? So to conclude, you may say, therefore, the odds of giving birth to a boy are 1 because it's odds, yeah? Whereas the risk is 0.5. يعني, if you think about it, it's a bit of a complicated thing, but it's easily followed. There is a difference between risk and odds. الريسك غالبا cohort. الodds غالبا case control. الريسك غالبا you are following their up. الodds غالبا you are looking at what they were exposed to. الاثنين فيهم رقم واحد. إذا وصل رقم واحد, if it's number 1 or you have the number 1, means that there's no statistical significance, يبقى a null hypothesis wins. لو علي, يبقى it is increase risk, increase odds. وطي, decrease risks, decrease odds. يبقى هنا ايش الريسك of you having a boy؟ لو تيجي تفكر فيها we're following up. يبقى لما تسأل واحدة لسه عمالة حامل جديد, the risk of her having a boy is 50%, isn't it? So that means that the risk ratio is 0.5. Whereas, what are the odds of having a boy? Well, you can have either a boy or a girl. So the odds of having either or is 1. فاهم كيف? So there is no difference because both of them have equal chances of having that outcome. And both of them, you would have to be pregnant to get them. So the odds are 1 that eventually you will have a boy or a girl, and it's not significant. Always check in case control studies that the authors have used odds ratio, اتذكروا هاي, rather than risk ratio. أحيانا authors, they use risk ratio and this is wrong. So when you will be reading a paper, remember those very simple basic things, okay? So now it gets you to your kind of homework. What you will do is you will download this paper and you will complete this time another survey. You can either scan via phone the IQ code, the QR code, and that will take you straight into the monkey survey, yeah? Or you can copy and paste the link, or you can email me with your answers. So just to put it simple, this is a picture taken last year in London, in Greenwich. Next will be critical appraisal. And just to put it simple, I will show you how the homework will look like so that people understand it. So simply putting, you will go into PubMed, yeah, and then so you click on it, you go to the PowerPoint presentation, I can email it to you, I'm more than happy to do so, and you just copy and of course paste the number of the article. So that's each article research has got a PubMed ID. And this is basically your article, pain control in laparoscopic surgery, and it's a case control study. And then after you download the paper from here, if you can't download it, just simply go to Sci-Hub. Yeah, Sci-Hub is a very nice Russian kind of site where you can actually copy and paste the link into it, here, and then you'd open a paper and it will download. After you read the paper, you go into the Survey Monkey. You copy it and paste it. I'll show you how to do it. And it should take you straight into the survey itself. So you fill in, it's always 7 questions. What is the journal name? And what is the impact factor? It's your bits to find throughout the article. And you will follow all the questions. And don't forget to write your name and email, because that will be a proof of your attendance as well as a proof towards your certificate. As part of me being a researcher, as well as asking myself, I thought I'd just Google why they call it a t-test for the parametric test. And it seems like in the olden days, if you read it, there was a very famous Carl Pearson, and they were publishing in between Oxford and Cambridge. And they usually used to publish their paper in an anonymous name. So he has put it as an anonymous student. And because it's a t-statistics, they abbreviated the hypothesis statistics. They abbreviated as the T from the hypothesis test. And then because it was an anonymous, they've abbreviated as a student. لأن كل واحد كان لازم يحط اسم مستعار. And hence it came as T students test, just for the fun of it. So always ask your question, why did they do this? How did that happen? And this will slowly develop your mindset towards being a researcher. Again, if you have any questions in regards to this very nice and heavy topic, I'd be more than happy to answer. Meanwhile, I just wanted to quickly go through in the last 5 minutes of what we had today for those who join later. Today we are on our 3rd lecture. Next lecture will be critical appraisal. We briefly talked about the different studies and the hierarchy and how strong they are. Then we said that there are 2 types of data. After you collect them, you plot them, and you have either skewed data, منحرفة, or normally distributed, وهاد أساس كل statistics. If you understand this concept, you will understand everything. And simply putting, there are two tests, parametric and non-parametric. The parametric is for normal distribution. Non-parametric is for skewed data. We knew that there is parametric tests. في عندك اثنين, t-test و chi-square test. This is the most common use, is a t-test, and is to compare different samples. And we knew that there is ANOVA and that there is chi-square test. And then we had this example. And then we tested it, and then we went into non-parametric tests. We said non-parametric tests are for testing not normally distributed data and skewed data. And then we had this example where we saw that the nurse had different ages and groups, and we used the median because it's skewed. And following that, we asked the statistician to calculate the p-value and use a non-parametric test, which was here Mann-Whitney U test. And then we knew a little bit about the difference between those. And then we moved about life. And if you exposure, and there's an outcome. And you can either follow up a person from the exposure to the outcome, or somebody can present with the outcome and you just ask what was the exposure. And then we spoke about the risk ratio, and we said it's in the cohort studies. And we know now what is risk, and you know now what is risk ratio. And we said that the significant number to know is 1. Why? Because it's not significant. And it shows that the risk ratio or the odds ratio is not significant, which means that the mean wins, the null hypothesis wins. And when we gave this example of a cracking leg, and we followed them up of those footballers, and we calculated the risk ratio. And then we moved on to the odds ratio, where we spoke about what is odds, الاحتمالية, and we knew that this has already happened, يعني الoutcome صار. And we knew also that this is mostly in case control studies. And the last bits that we need to know is that number 1. Again, if odds ratio is 1, means that there is no difference. يبقى mean wins, the null hypothesis. If it's more than 1, increase, less than 1, decrease. And we had this example about the outcome, which was knee injury, and we matched them, and we found out skiers versus non-skiers. I've corrected it here, okay? And then, of course, we calculated the odds ratio, and we asked the statistician to help us with the confidence interval. And we've concluded that we have always to check case control studies for odds ratio. And at the end, I spoke a little bit about the homework. I hope that I was very useful today in making it simple. And don't dig too much into the details, because it's slightly complicated. All you need to know for writing papers and understanding a paper is what I've similarly put into your view. Now, if you have any questions, please do not hesitate to write them down or to unmute and ask them. I'd be more than happy to answer those. Meanwhile, for all the others, I hope that you did enjoy. And in this very last minute, I'm very proud of each one of you for answering the questions on the monkey survey. They were relatively difficult, but to tell you that almost 100% of people actually answered them correctly, which means that the understanding of the basics number 1 lecture was as per wished aim. Again, thank you very much for joining me today, and let's catch up next weekend on Saturday at 7:30 again with critical appraisal. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.